but maybe a little sooner. But please stop and ask questions if you want to. The point of this was to be more technical and have fun and kind of explain something. And then, obviously, I'm not going to leave during Nick's presentation, even though he made a joke about other people leaving after. But I'm going to stick around because I'm interested in what he has to say too. And then if you have questions at the end. So that being said, it is 4 o'clock. So my name is Tom Ryan. I think most of you might know who I am. If not, I'm a director of IT from Rutgers in New Jersey. I am actually a campus employee. I know that there's like this whole back and forth, but I've been in law school for a long time. I think this is my 20th Cali conference. It's pretty close to around 20. I've missed a couple. I've been coming since the early 90s. So I was talking about pfSense. HaProxy, there's a little bit of a debate about whether, and I noticed Nick calls it HaProxy. I sometimes call it HaProxy. I sometimes call it HaProxy. I'm not really sure. I think it's HaProxy. I'm not 100% sure. What do you think? I don't know. And Snort. There's 3 open source products. So all I've got here is a quick little description. pfSense was started, the project, they actually call it a project. It was started in 2004. That's one thing I'll say is all these are pretty mature products. They've been around for quite some time, and they're of course, actively developed. In addition, it is an open source. I just said that. It's based on FreeBSD. It has pretty good support for third-party packages for enhanced capabilities. We originally moved to pfSense because we had a handful of Cisco ASA boxes. We had some SonicWall hardware devices. All of them cost us quite a bit of money up front, and they all cost us significant money in yearly maintenance fees. And what was happening for us was budgets were getting tight. We didn't necessarily have money to always fund that. At one point, so I think at one point we had, after we merged, I think we might have had 11 or 12 different hardware firewalls spread across our campus. And the reason for that was that we don't control the network, so we couldn't use anything like MPLS or what have you to route traffic all through a central firewall. And the university doesn't have a policy of traversing VLANs across buildings. And so, if we had our police department over here, they had to have a firewall. If we had somebody over here, they had to have a firewall for different reasons, GLBA, PCI compliance, what have you, HIPAA compliance, and everything else. And the other downside was not only did we have singular firewalls out there, we had singular firewalls. So if one of them went dead, we had a problem. Not only because we had to get it up and running, but we didn't have the money to necessarily have another box. We had a SonicWall box. It died. We replaced it with pfSense. It's been pretty good for us. The other thing that's really nice is, like I said, third-party packages. That's where we got HaProxy and Snort. And it requires, as of the 2.3 release, 64-bit hardware, or you can run it in a VM. We do it on both. Our primary is virtualized, but we do have some hardware boxes. In fact, I'm going to do a quick demo at the end. I brought a little hardware pfSense box with me. So this is just an example of what the config page looks like. It's pretty small. I actually took it from our virtualized instance. It shows you on its dashboard, you can see the different interfaces that are configured. I don't expect anyone to read it, but it just kind of gives you a quick little look. You can see we're running at 27% CPU usage. We're using 13,920 states. We've been up for 40 days. This particular unit's been up for 40 days. This is synced between another unit. So that's pretty nice. Lets us do all of our updates. And you can also see the Snort alerts that right there on the thing. So it's kind of nice. You can take a quick look at that. You can see what's going on. The nice thing about pfSense is not only do you get firewall capabilities, but we have several VMs. So we have one VM that does all of our VPN connections. So we land all of our VPNs into a different VM that we have. And so this is where we go out to remote sites and what have you. We tunnel everything in. Those remote sites are running Cisco boxes. They're running SonicWalls. They're running whatever. Usually the downside is we have different protocols and what have you that we can run. But again, we can do all of that. We can update it. It doesn't cost us any amount of money, so we're pretty happy. We also do mobile clients through the system, not just site-to-site VPNs, but we do mobile clients. So we have a IT-only VPN that lands our IT staff into one network. Then we have a general user VPN that lands them into another network. The really cool thing is that, and there's one little bug with it that I'm sure Tim will complain about when I say this, but anyone in here use Duo or something like that? So we've tied our VPN into a Duo proxy. So for that staff member, for the IT staff members who come into our VPN, have to use Duo two-factor to get into our VPN. So we're pretty happy with that. The only downside with that is we found that, and this is too much echoing, I don't know if there's a volume thing, is that the Mac OS built-in VPN client is actually based on, I think, Raccoon, and it's buggy, and you can't actually adjust the lifetime of the client off, even though it's configurable on the VPN side. You can't do it in the client. So whenever the Mac client decides to re-off, you have to sign back in. So it's usually about 54 minutes at a time. And the nice thing is that if you see it happen and you just drop and reconnect, you can continue your sessions. It doesn't actually drop any of the sessions. It's just kind of a nuisance. So we're pretty happy with that. A little neat factor. We've moved all of our servers to two-factor authentication, and our VPN for IT is two-factor authentication. Our general users, we don't require two-factor yet. I know there are some, so we're part of Big Ten. I know there are some Big Ten schools. I think Harvard, anyone here from Harvard? I think Harvard is in the midst of a mandatory Duo rollout. I know Penn State went through a mandatory Duo rollout for all of their staff. Rutgers has not decided to do that yet. I think it is coming, though. IU? So I printed out just a kind of a screenshot. A lot of this is screenshots. This is some of the available packages that you can add on to pfSense. Again, it's all built within the GUI, so you can go right into it, and you can scroll up and down. There's probably 50 packages that you can add. Some of them are pretty neat add-ons, and some of them I think are worthless. But there is a whole bunch of different capabilities that are in there, so you could really extend the capability of the unit if you wanted to do different things. As I alluded to before, we only use on this system the HaProxy, Snort, and of course we use the OpenVM tools so that the unit can communicate better with VMware for doing Hyper-V and what have you. So it's pretty simple. They just install. Again, when they go out of date, you can just click this little box. I don't know if you can see it here. There's some different icons, and you can automatically update. It'll preserve the config, what have you. The only thing I will tell you is that Snort sometimes is a little buggy. There was an update recently that when we updated it, it referenced in the config, the old config had a different library file, and so when we updated it, it didn't update the config to remove the reference to the config file to that older library, and so Snort wouldn't start. But looking at the log files, you could real quick see like what it was going on and fix it. So literally took 5 seconds to fix after looking at the log files, and of course logs are freely available, easily accessible. So the next product that I want to talk about is HaProxy. They call this a product. That's why I have it in quotes. It's not a project. It's not software. It's a product. And it was started in 2000. So again, very stable, very mature project. As the name suggests, it's primarily an open source, high availability load balancer and proxy server. I don't think they're very creative on their name. It provides DDoS protection, HTTP reverse proxy, THCP, HTTP normalizer, blah, 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 blah. It also has what I think is the ugliest icon out of all three of these products. Obviously, I don't think they've updated that since 2000. That looks like a GeoCities 2000 icon. It's used by GitHub, Bitbucket, Reddit, and AWS with the asterisk because, as I said, not really sure where it's used there, but it's apparently used. It's pretty neat, pretty capable stuff. So I put everything again here on just one screen, and when I get, hopefully I keep moving along pretty quick here, you configure front ends and back ends. It's pretty simple. So you just go in, you can define your front ends. Basically, it's all integrated into the pfSense. If you use HaProxy, again, just very quickly, obviously, for any of you that don't realize this, none of these tools all have to be used on one. I'm talking about them being all used on one platform, but you can certainly run HaProxy and Snort on whatever flavor of Linux that you want to run it on. There might even be a Windows port, which I don't know why you would want to do that. So you make your configurations. I mean, I don't have them up. I'll show you when we go on the screen because the screens are too large. There's too much information to set. But you can see some of these are the things that we've defined. We have an LDAP running through our HaProxy instance so that Obviously, we have high availability of our LDAP service. Of course, this doesn't do any of the setup of the sync, so we had to set up our syncing of our LDAP servers so they sync all the data between them. But once you set that up, this will push off those requests. We have our front end, both SSL and non-SSL. We have SMTP services coming through here. We have SMB services coming through, as well as database. So we have multiple database servers that can be pushed through here. And then once you configure your front ends, you have to go and configure your back ends. One thing I will tell you, this is more of a technical thing. There's several different persistent states that you can set on HaProxy for how you use your back ends. What we found is we had to use sticky by IP, and the reason why was because our transactions, our HaProxy instance is too fast for our NFS caching on our Metro cluster. So when we were not doing it that way and choosing to do it other ways, we weren't getting transactions right. Some transactions we write to disk. Specifically, we use WebDAV for file sharing, and we have different front ends on that. Totally off topic a little bit, but so you just have to play sometimes with the different settings that you get. There's a lot of different features and capabilities available, so you got to play with what works. And while we had to do a little bit of that with HaProxy, Snort is even more temperamental. Has anyone in here ever ran Snort? Yeah, so you know, Snort is a tricky beast. So the next thing you get with HaProxy is you get some pretty cool stats that will tell you where you're at. So you can see this is for 15 days of uptime on 2 of our servers. We had 38 million sessions to our backends over SSL, and almost 6 million on HTTP. We've been trying to force most of our traffic over HTTPS, and this gives you all kinds of different data. You can see we've got one server that's been in maintenance mode. It's because we're testing a migration from operating systems. We're moving to PHP 7 from PHP 5, and so that box is what we spin up or spin down to do different testing, so that's why it's out. But you can set maintenance mode, you can set like primary failovers, secondary failovers, you can do all your stuff. As you can see from us, we run our website on 3 virtual servers. Those are all virtualized boxes sitting on the same VM spread across obviously different nodes in the VM. Any questions while I'm moving along here? Okay. So the next and final thing was Snort, which I think has the best logo of them all. Obviously, they were started in 1998. They have since updated their logo because I don't think it would have looked that great back then. And if you Google, you can see it's been changed over the years. It's an open source network intrusion detection and prevention system. So anyone that's ran Snort is pretty neat. It can detect, and in this configuration, it will also prevent. Because it performs real-time traffic analysis and packet login. And then I don't know why, just for lack of a better thing, I wrote detects and protects as well as HaProxy, DDoS, SQL injection, buffer overflows, port scans, etc. And the way it does that is by going into the configuration. Again, pfSense makes it easy, and you can bind your Snort interface to a VLAN. So this is our externally accessible VLAN. It's where we've bound Snort to. And so this doesn't give you an example of all the different options. You can see the tabs at the top where you can configure different things. But if you also configure the interface itself, you can set all kinds of settings. And this makes it real simple for people who don't want to read the documents and just want to click, click, click. The Microsoft way of administering a system in a nice little GUI. Again, once you get it configured, you can get different rules that get updated on it. So we actually pay for a subscription to the Snort VRT rules. We do that not because we have to pay for it, but as a way to support the project because we use the software. We have those rules. That's why we don't use the community rules. And then when you read about on all these, they can kind of tell you the different ways. And you can set the updates to happen automatically or to do them manually. I will tell you that in my experience, the automatic updates don't always work. Sometimes they put out a bad update, it won't start up again, and you won't know that. There are some, one of the optional packages that you can add on pfSense is a watchdog, service watchdog daemon. The problem with that I found is Snort takes a little bit longer to start, And sometimes the watchdog daemon won't think it's not really started and start it again, and then you might up with 8 instances of Snort running. And if you want to talk about high CPU load on any box, that is an easy way to have your CPU go to 100%. So we usually do ours manually. So if you're just sitting on top of it, I mean, the downside is the rules get updated pretty frequently, and so there is that a little bit. But I advise everyone to do it. I think it's gotten better because we've turned it on from time to time to play with it, but it's not always perfect. So the neat thing that we really like about it is, when you're configuring it, you can configure what you want it to do with bad hosts. So we have ours set to block them. And then you can set how long you want them to be blocked for. So you can block them for an hour, 2 hours, 15 minutes, whatever. There's like maybe 6 options in the drop down. And if you hop over to the command line and play with it, you can make it even more customizable. But as you can see, it gets threat lists, and then there's MSSQL port traffic. It senses that there's nobody on the outside trying to connect to our MSSQL server. If they are, they're up to no good, obviously. This is where it gets tricky, though. If you start using this and you use it in production, you have to sit there and watch it. You cannot turn Snort on in production and walk away. If you do, I guarantee you will get a phone call that your website is down, that something's not working, because Snort, out of the box, is overly protective. So that's my warning to anyone who uses it. Don't turn it on and walk away. We actually have pass lists where we look at different traffic and say, if it's Rutgers traffic, it's kind of okay, not always okay, and you can do different things like that in the config and set up different networks that you want to trust out of the box, other ones that you want to apply certain different rules to and what have you. So you just got to spend a little bit of time to configure it. It'll do that here too. Yeah, absolutely. Yes, you do not have to turn on prevention. You can uncheck that box or not check that box, depending. I don't know what the default is. We check that box. The nice thing is, I said earlier, I don't know if you were here or not, but we've caught and identified SQL injection bugs through this thing, which is pretty nice. We have people who host websites. Well, we host our sites for them, but they write their code. And I love when they tell us they don't need our help, they know what they're doing, and then I get to write and say, you have an SQL injection in this this code. Please fix it. So it's pretty nice that it catches that stuff in real time. The only thing I would tell you is that the reason why it's able to do that is because since we use HaProxy, we're offloading all of the SSL on the instance, so we're seeing all of that traffic. If you were running Snort and you were doing like TCP pass-through or what have you, Snort would not be able to see any SSL traffic, and so therefore, SQL injection, things like that, would be worthless. So it's just something to keep in mind. Good. It's 4:18. I'm doing good. So with that, I had questions and comments, but what I'm going to do real quick is jump over to this box. So this is a little, I'm going to try to take 2 more minutes, Nick. This is a little pfSense. It's from Netgate. This is a little box. I think this is $300. If you look on the screen up above, you'll see, if I can move my mouse correctly, this has hardware crypto built into the box. This is a little bit nicer than you would get. There's a cheaper model. They actually came out, so it's like $150. But as you were saying, you can run pfSense. It's free, so you can put it on any computer that you want. You only have to have, ideally, you could trick it and run it with one network interface if you did VLANs on it. But most people, I would recommend you have a dual port network interface, which is what this box does. It'll support VLANs if you wanted to. If you do VLANs on this, if you are using it, you make sure you configure your switches for layer 2 loop detection and isolation. Otherwise, you will create a loop if you do multiple VLANs on this. If you do VMware, which is what we have, there's a setting, I don't remember off the top of my head, but there's a setting you got to put in VMware so you can run all of your things in there without creating layer 2 loop issues. We had some issues with Juniper firewalls. We used to have, not firewalls, Juniper routers. We used to have Cisco routers. We moved to Juniper routers, and it created some issues with us, and we had to do some fancy things to get these to work with multiple VLANs. And of course, I'm demoing this to you, and I just knocked the power cord out. So we're not really going to demo it too much, especially since I'm getting really close to 420. The nice thing about these is, I was saying before, that we used to have a whole bunch of Cisco ASA firewalls and some sonic wall boxes. We support not just the law school, but a whole bunch of other departments on campus, our health services center, our police department, our business office, financial aid office. For different reasons, GLBA, HIPAA, PCI, we're required to give them hardware firewalls as a compliance measure. And the university at the time did not have MPLS or anything like that, so we had to go out and put firewalls in all these different places. And so we had a whole bunch of Cisco's that were costing us $5,000 and like $800 a year in license costs. Needless to say, getting the department to give us money to fund the license renewal was always a little bit of a tricky discussion. And so we've since moved to boxes like this. We actually have some computers that we repurposed in some locations, and they work great. And we pay once for the hardware if we even buy the hardware. And software updates are free, and the logging is pretty good. So much. I brought all that and set it up, and all I'm showing you is the page, which you can't even see because my extended desktop is not up. That's weird. Okay. Why did that? Oh, it's because of PowerPoint and extended screen mode. So, any questions? Anyone?
So, network topography is that your pfSense sits forward of everything. You coalesce everything in a proxy and watch the score.
Yes. For the server networks. And we have, so in addition to this VMware installation, which I brought up, those were screenshots, which does all of our primary servers. We also have another pfSense virtualized instance, which we have some of our distance learning rooms are sitting behind that, printers, other things where we've got firewalls. We've done in other locations where we haven't implemented the hardware firewalls is we just have access control lists on our routers. For something we don't need logging, because obviously you can't do any logging on ACL, we just use them if we don't need a log. The Snort runs on the firewall. Runs on the firewall. Same instance. It's Snort, HaProxy, and pfSense. Because HaProxy runs on the same box. They're all three are on the same VM. They all run on the same VM. The other thing I was talking about is there is a way that you can pull pfSense out of the equation. I mean, not pfSense. You can pull Snort out of the equation, run on a different box, but then it won't see the encrypted traffic. You have to run Snort if you're terminating. And so my recommendation would be if you do this setup and you want all these capabilities, you have to land and term your SSL and forward in the reverse proxy. You can't do a TCP pass-through where you won't see the SSL traffic, and you're not really getting the full bang for your buck. Yeah. Well, I want to do that anyway. I maintain certificates anyway because we have everything turned on and checked for certificates. Versus an untrusted certificate. So, any other questions? Was this technical enough? Too technical? All right. Okay. And with that, Nick, look at that, 423. Come on, 424. That's pretty good. All right. Yeah, sorry. I'm going to go real fast.
Hello, everyone. And of course, it's backwards. Oh, that's lovely. Let's play this. right. I'm going to use up all my time just switching monitors. All right. All right. How's everybody doing? Okay, who's seen a presentation I've done at CALIcon before? Anybody? One. Okay, so Dan will recognize this slide from one of my previous talks, and this slide from another previous talk. So I had a talk called The Afterburner, where I was talking about optimizing Drupal for speed and SEO. And then I had a talk called Second Stage Booster, where I talked about optimizing both Drupal and WordPress, again for speed, SEO, and then social media. So, but there's one thing in common between those two things. Can you sense a theme going on? All right, so today I'm going to talk about taking your website to the next level as far as speed is concerned, and going as close as possible to instant using HTTP2 and AMP. I'm trying out this Google Slides thing, so if you have questions, theoretically you can go to that URL and the questions will pop up on my screen over here. So we'll see how that works. All right, so why does it matter? So there's a recent study has been shown that says that 75% of users will leave a web page if it takes longer than 10 seconds to load. And load is the full experience, not time to first byte. It is, if it's not done loading in 10 seconds, they'll get bored, they'll leave. And then Google ran another little study, and they went through all of their mobile search results and the pages that come up, and they found that 77% of mobile web pages take longer than 10 seconds to load. So if you do the math there, take those two studies together, that seems like somewhere around almost 60% of users will leave every web page on mobile, loaded on mobile, because they took too long to load. So, and I'm sure you've all had this experience. You're doing a search on your phone, you hit the link to pull it up, you sit there waiting for it to load, and never loads, and you're like, screw this, and you get out of there and you go somewhere else. So, in my previous talks, I talked about optimizing the server side. That's the blue wedge there on the corner. So optimizing the server side, making sure that your page doesn't, it doesn't take 3 or 4 seconds for the HTML to be before it even gets sent. But what can we do about the other pieces of the pie here, which is the purple wedge here is data transfer, transferring data to the user, and the yellow wedge there is page rendering. So how can we optimize that? So obviously the answer to the server for the data transfer is to just ask all your users to get faster internet. I think we should all just do that. Just everybody needs to get faster internet. We're good. Since that's not possible, let's see what we can do to optimize that. So what we have here is the working draft group for the HTTP 1.1 specification, which you've probably used several times today to load web pages. And just want to highlight the date there of June 1999, which is when the HTTP 1.1 protocol came out, and there hasn't been a new version of it since, until now. So fortunately, it's finally time, after 18 years of the same version of the most common protocol we use on the internet. There is a new version of it. It's called HTTP 2. And so let's talk about the differences between HTTP 1.1 and HTTP 2. So HTTP 1.1 has a whole bunch of things, because it was written in an age when web pages were simple. Plain text, HTML file, maybe you have CSS, but back then that was rare. Maybe you have some JavaScript, a couple icons, animated cat GIFs. But It wasn't complicated. But as web pages became a lot more complicated, then things became a little bit different here. I just realized I can't even read my own, I can't see my slides in this little presenter view. This is wonderful. So HTTP 1.1 is a plain text protocol. HTTP 2 is a binary protocol, which is much more efficient for transferring everything other than plain text, which even plain text mostly these days isn't plain text. Plain text, you almost always use gzip compression when you're transferring HTML, at which point you're transferring binary anyway. So using a binary protocol makes much more sense. It has much less overhead. Yeah, I can't read my slides. So I'm just going to put them all up here. I thought I was going to be able to read my slides. Now I'll move over here. All right, so HTTP 1.1 is you use a separate connection for every resource. So you load your HTML file, then you load your image, then you load your CSS file, then you load, every single one of those things requires a separate connection back to the server. HTTP 2 is fully multiplexed. You use a single connection. I'll show you that on the next slide here. And that's much more efficient, and you can actually transfer a lot more data at the same time. And you don't have the constant round trips back and forth to the server. HTTP 1.1, the HTTP headers were uncompressed, even though they were plain text, and plain text compresses very easily, and repeated on every single request. So that added a lot of overhead. And HTTP 2 uses HPAC header compression, which is fantastic. It just really brings those headers down to manageable byte sizes. I'll talk about ServerPush in a minute. The other thing is every single one of those separate connections, because they were separate connections, required the whole SSL handshake to happen if you're using HTTPS. Whereas, and that was a slow compression technique where HTTP 2 uses ALPN, which is much faster, and you only have to do it once. And then the concurrency limit thing is also about the multiplexing. So let's talk about multiplexing real quick. I already kind of went over this. HTTP 1.1, every single file that you request is a separate transaction. In HTTP 2, everything comes through a single tunnel. So you make one TCP connection, everything goes through it, and goes bundled on the other side. And so ServerPush. So your typical thing, you say, I want an HTML file. Server sends back the HTML file. You read the HTML file, it says, I'm going to need a CSS file. So you go back to the server, says, I need a CSS file. Server answers back. With ServerPush, when someone says, I need an HTML file, you can say, here's your HTML file, and you're going to need this CSS file too, and these JavaScript files, and these images. And you basically pre-start the responses that you know that the browser is going to ask for anyway. And this allows you to prioritize content on the page. So you're probably saying, this all sounds good, but it's a new technology. We all know that browsers take forever to adopt new technologies. When can I actually use this? The answer to that is you can use it now, because every single browser, every single current browser, except for the mobile version of Opera, which hasn't been updated since 2013, supports HTTP 2 right now, including IE, believe it or not. So now the caveat with IE is that it's only IE 11 on Windows 10. So, and the caveat with Safari is Safari doesn't support ServerPush yet, but it's going to. But the modern version of every browser supports HTTP 2, and if you're not using a modern browser, the HTTP 2 seamlessly downgrades itself down to HTTP 1.1. So there's no reason not to do HTTP 2 now. So I'm going to, rather than keep going on and on about its things, I want to actually show it to you. So I've created a little test site here. Open up the inspector. Alrighty. So first of all, let's load this in HTTP 1.1. Okay, I took a large image and I chopped it up into 600 tiny little images, and I laid them out on a grid. The stuff on the red part are image tags. Stuff on the green part are loaded as CSS backgrounds, and the stuff in the blue part is loaded by a JavaScript, which is why it goes to the very end before it starts loading. And it's still loading. This is HTTP 1.1. Now, for my little test here, what I did is I loaded. Did it finish loading? It did. 26.71 seconds it took to load that. Now, this is obviously a ridiculously extreme case, but it shows things off very well. So, I'm going to point at the exact same folder. Let me just bring it in so I can actually see the URL bar. All right, let's load this exact same page, exact same images, everything, but under HTTP 2. All right, so this is a straight HTTP 2. I'm not using ServerPush on here. That is just the advantage. This is actually the same server. Both of this is a single installation of Apache, one set up with HTTP 1.1, one set up with HTTP 1.2, and that took 9.87 seconds, so a third the time. It's under 10 seconds. Under 10 seconds for 600 images loaded by 3 different means for 3 different JavaScript files, a CSS file, everything finished rendering in under 10 seconds. So on both of those samples, you saw that blue section was the last thing to load. So, and that's because it's being loaded by JavaScript. So the JavaScript, the JavaScript has to be loaded, and then the JavaScript has to be run. So, it still feels slow. So what if that was something more important than the bottom third of an image? So I have a third example here using ServerPush. So on this one, I server-pushed the JavaScript files, the CSS file, not the CSS images, and the last third of the images. Now, because you do use HTTP headers, you can't send all 600 images through ServerPush. I tried first, crashed everything. And you'll notice that the stuff that's being loaded by that JavaScript actually loaded first. And that's because I was able to use ServerPush to prioritize my content. And now it's still 9 seconds, but it's 9 seconds that I can control. When I was doing these samples at home, I actually got this down to 2 seconds. So that's running HTTP 2 and doing nothing but just running HTTP 2. So pretty cool, right? All right. Now I got to find my browser windows. Where are you? Dang it. Presenter view. There we go. All right. So what do you do to, this has got to be a lot of hard work to set up, right? How do you do HTTP 2? I know you all want to know. If you're using Apache, it's a core module released in 2.4.17, yeah, and later versions. So if you're running Apache 2.4.17 or later, you already have it. You just need to turn it on because it's not turned on by default. So enable your module. If you're using a Debian-based system, you can use A2nmod, or you can just load the little load module line into your config, and then add this complicated code right here to your vhosts. That's it. One line. Protocols, H2. You can even take the H2C part out because it doesn't actually work. Well, it does, but no browser supports it. And then the fallback to HTTP 1.1. So you're basically just indicating I want to support HTTP 2, HTTP 2C, which is HTTP 2 over non-HTTPS, which is it doesn't quite work, and fallback to HTTP 1.1 if it doesn't. If not, if you want to use Nginx instead, well, it's a core module. It's a core component as of version 1.9.5, and all you have to do is add HTTP 2 to your listen lines. That is it. That's enabling HTTP 2. If you're using IIS, I'm sorry. But supposedly it's pretty easy to do there too. In fact, it's supposedly a matter of checkboxes that you check somewhere. But I don't know exactly. Is that still too hard? Am I running out of time? I am. If that's still too hard for you, many popular CDNs, if you use a CDN, have added HTTP2 support, and they will add HTTP2 support on top of your website for you. So Akamai, CloudFront from AWS, or Cloudflare, all you have to do is say, I want HTTP2, and they will take your HTTP1 website and serve it as a HTTP2. Cloudflare will even do the ServerPush stuff for you, even if you're running an HTTP1 server. So that's pretty cool stuff. If you want to do ServerPush, the way you do that is with a HTTP link header. So you add an additional header to your output, and you get, it's called a link rel preload, and you just put in the URL and what type of resource it is. So as script, as image, as styles. What if you want to do it on HaProxy? Technically speaking, you can't. Not if you are using the HTTP proxy method. You have to use the TCP proxy method and pass it through to the endpoint, in which case it will pass the HTTP2 from your target servers on. I'm not going to go into how to do that, but that URL up there is a great blog post explaining how to set up a Nginx based and HaProxy based load balanced array of HTTP2 based resources. So we've optimized our server side, and with our previous presentation, we've optimized the data transfer between user and server with HTTP2. So finally, let's see what can we do to optimize render time. There's lots of different ways to do it, but the way I'm talking about today is AMP, which is Google's Accelerated Mobile Pages project. I don't have time to go into detail about how to use AMP. I'm just going to explain what it is. AMP is both a superset and a subset of HTML created by Google as an open source project to create versions of pages that can be pre-rendered and loaded instantly. So there is a specification of HTML, which you can find on ampproject.org. There is a JavaScript library you have to load, and there is the AMP cache, which is hosted by a bunch of third parties, including Google. And so what happens is, rather than loading directly from you, if you run an AMP page, it shows up in Google. They tap that, they're actually loading the Google cached, pre-rendered version of the page. In order to make AMP load instantly, and it really does load quite instantly, you have to deal with some limitations. AMP is statically laid out, so everything, including image tags, have to have a width and height. So they lay out, because of this, you're able to lay out the entire page and determine what's going to be in the view, and they optimize the loading of the things that are in the view. So any image tags that are not on that first page view will wait to load after everything that is in that first page view is loaded. And I can't see my own slides. So you can only use 50 kilobytes of CSS in your web pages, and it has to be on page. It can't be an external CSS file. And no JavaScript. None at all, other than the AMP JavaScript library, which you have to have. So there's like, no JavaScript, what's the point of even trying? I can't do anything. Well, you can. So first of all, AMP's based on web components, which is a method of creating your own HTML tags, essentially. They've created a number of rather oddly named HTML tags, which I'm just listing here. We got AMP accordion, AMP, AMP YouTube to enable it to embed a YouTube video. It's just a number of different things that would normally you would do with a bunch of JavaScript. They bring it down to a specific component. They have carousels and accordion, all sorts of different things. If you want to do binding, where tapping one thing updates something else, they have amp bind, which they like to call JavaScript Lite. And if you need something that's truly complicated, you can use iframes, as long as those iframes are statically laid out with a height and width, and those are always loaded last. So, what do you get in exchange for following Google's limitations? Well, first of all, in the search results, you actually get a little, you probably can't see it in my little demo here, but you get a little badge that shows up on your posts that says that it's AMP related, it's optimized. You might also show up in the carousels if it's a news-related piece. If you tap it, instead of loading to your page directly, an iframe pops up in the Google search results page, and the pre-rendered version loads pretty much instantly. You notice that does create a little bit oddity where it looks like it has two address bars because they create a fake address bar inside the browser. And if you tap that fake address bar, that's where you can get the real URL. How do you do it? Again, I don't have time to go into all of that, so I'm just going to say the specifications. There's ampbyexample.com, which is a site that Google put together with example layouts and stuff like that of how AMP works. There's ampproject.org, which is their specification where you can read about all the components. Or you can just install a plugin for a CMS system. This is the official AMP plugin for WordPress. And this is the better AMP plugin for WordPress because the official one really, really sucks. And this one actually works pretty well for actually basically just taking all of your content and pre-rendering it. So if you're using pretty much any popular CMS system, somebody's probably already made an AMP plugin for it. Drupal has an AMP plugin made by Lullabot. Laravel has an AMP plugin also made by Lullabot, oddly enough. That is actually all I wanted to talk about. So I'm going to use what little time I have left to ask if anybody has any questions. Did anybody somebody put something in. Pre-rendering sounds like what Opera and maybe Amazon tried to do. Yes, very much so. The pre-render, that's exactly what. Hey, that's cool. I've never used this tool. Yes, the pre-rendering that AMP does is very much like what Opera does to optimize stuff, which is to say that they essentially boil the HTML down and transmit it as a little package. It's a little bit more than that. They basically redo the components in a very fast and optimal way. The main advantage you get is because of that static layout and because you're not actually using the tags that the browser would normally just do its own thing about. Like, for example, an image tag, if you have 50 image tags on a page, the browser's just going to load them all. You saw when I did the HTTP 1.1 example, it wasn't loading sequentially. It was loaded this one and then it loaded that one. It just all over the place. But by using that statically, the AMP image tag instead, it's able to actually do it. So you put another thing. Yeah, Silk browser is a lot of that. But this is something that is supported in pretty much all mobile browsers right now. So Safari, it is supported in Safari. It is supported on iOS. It's supported in Chrome on Android. Those are really the only two that matter, but the other ones it does support as well. So, any other questions? So yes, you have to be running HTTPS in order for HTTP2 to work. If you put that line in an HTTP vhost, it won't error. It will just, It'll just downgrade everything. So the H2C, technically it will allow some parts of HTTP2 to work under HTTP if there was a browser that supported it. but there isn't even one. Not one. So you can put that line in there. It'll work fine. It's just that if you load it under HTTP, it will downgrade down to 1.1.
I'll just add that HaProxy looks like it's 5 to 6 months out.
Yeah.
Fully supporting.
But it also looked like it was 5 to 6 months out a year ago.
And
So.
2 years ago. Developers tweeting that.
Yeah.
Are working through the concept that's relatively recent.
Mhm. So. Anything else? No?
So is the AMP specifically mobile only?
So AMP will load just fine on a desktop. In fact, if you go to ampproject.org, their page, the page itself is an AMP page. Typically speaking, what you do is it's like going back to the old WAP days, you make 2 different versions of every page. You make a AMP and a non-AMP version, and you use the canonical tags to associate them together. So Google's only really pushing it for mobile, so it only shows up in mobile search as far as the little AMP badge. There's nothing saying they couldn't support it on desktop. They just don't. But it will work on desktop. First of all, as the latest version of Safari on mobile, you no longer need the Polyfill for web components. They are using a subset of Polymer because they really wanted to make everything as lean as possible. So they basically took just the Polyfill part out of Polymer. Yeah. Yeah. But yes, it is based on Polymer for the Polyfill is based on Polymer. And they actually, even though you put one JavaScript link in your URL, they will pass a different, part of the whole reason that it's being served from Google servers is they won't necessarily, they change the URL you put there. So whatever JavaScript URL you put there, they change it to one of their own, and they will actually give a different JavaScript URL for Chrome and Safari and stuff like that, depending on how much of a polyfill they need, just to get it that little bit extra oomph.
So the other content served from Google.
Yes, your content's served from Google, or from Cloudflare, or from Baidu. Twitter's actually using Google's, but Twitter just added AMP support. So if somebody tweets a link to a page that has an AMP version, and you're using the mobile Twitter, the progressive web app mobile.twitter.com, it will actually load AMP there. So LinkedIn uses AMP on their mobile app and on their mobile web. Okay, I think we're done. Unless anybody else had anything else. I was surprised there were so many questions about AMP. Did you have something? Or you're just stretching. Okay. I saw a hand go up. All right, cool. Thanks, everyone. It did work out timing-wise. It would have worked out a little bit better timing-wise had I realized I wasn't going to be able to see anything if I used the presenter view. I couldn't.
I had it on and then I could see when I was trying to.
And then I should have just used mirroring mode and not had presenter view at all, but oh well.
Yeah. I'm also really talking for authority. Yeah, and everything we just talked about is I'm just trying. Well, like it's certainly, but HaProxy just web. And that you got okay. Well, that's different. Okay. Well, then I think because now we want people to like set up. I only think here's what I talk about all the time, but explain more about how.
the parsing and syncing works and how you have to, depending on how you set up whether you do a static route into your pfSense box or hard virtualize all your products. You have like virtual running instead of different boxes that we'll aren't on any of those IPs and then spread them out. It's nice to be able to, it's easy to like the HaProxy you're running. Oh great, I can take down a website and do whatever I want to it. Yeah. Without website. That's what I'm thinking as you're talking. Yeah. So downtime is extremely limited. And so what's misleading on this happening, I'm sure that this happening started only been up for 15 days. But that instance of HaProxy fails in 15 days because the other box is listening over the dedicated partner interface, and that goes down, and all the traffic just immediately shifts over to that box. And so it's really nice to not only have to be able to update your web server and touch your web server from here. I don't even care. I want to keep my web server. I can do it in the middle of the day. Yeah. And it's no longer like I gotta wait till Thursday night, 10 o'clock to make my change. From there, awake. Focus on it. But now I can also update, like when we originally did it, we only had the senior instance of the bouncer. So if I needed to update that, I would update that. Whereas now, I can update that too. And it maintains, so because of pfSense underneath, pfSense is syncing all the states across the sync interface as well. So everything, if you're connected in, if you're in the middle of transferring a file, it will continue to. So it's really, really, really nice. I guess if you were connected to a back-end web server, then it would do a retransmit TCP connection. So say we're updating and say, okay, can you do that again? But as long as, if the web server, the back-end server was up the whole time, saving is maintained. It's just, and we played with it in testing. Like literally, like we're SDKing a file, and you'll see 100 megabits of bandwidth, and then it'll just slow for like a millisecond or two, and then just continue.
It's session and why migration session.
It's the back of the box grabs all the MAC addresses of the primary. That's probably going to take a day. Well, when I was talking about exterior, there's really this whole thing I should talk about, and I don't want to talk about it. I really want to use these too. Yeah. But, as I'm sure you gathered from our talking, I really like these sections of packets. Yeah. With HTTP2, I would lose all.
Well, there is a way to do it. So
I rewrite Snort on all the individual web servers. Right.
Well, there's that, or you can see what, if you read the link, I put that probably in the rabbit hole, but there's this blog post that I didn't put up.
I think I copyrighted.
Yeah. So what they did is they put Nginx on the other side of the HaProxy.
Oh, it just transfer right there.
So Nginx can be run in proxy mode. So Nginx proxies to HaProxy. And what they did is they created two backend pools. A backend pool for HTTP1.1 and a backend pool for HTTP2. And then they had in the Nginx that's in front of HaProxy, if it's HTTP2, you probably get one port, port 81, and if it's shooting for port 82. And they
but all your clients are going to go with it too, because as you said, they all support it.
Right.
So it's kind of like, I hold out those. I mean, for us, the benefit of HTTP would be speed. We're pretty fast now. Our biggest problem now is people put non-optimized images. And so we would get benefit from that because, literally, I was just looking at our website, we get 12 images. And it's like, but my personal favorites are the upload little bio photos, where we set the width and height to be like, I don't know, 600 by 300 by something like that. People are uploading 3,000 by 5,000 images. And they still show up as this tiny little image, but when it goes on the page, it's like,
What if you guys use the CAS, right? The stats.
Well, so our website is the major hack. So the directory printed is Drupal content, right? But